You know, every single time you go online, something that's basically magic happens. Today, we're going to pull back that curtain and follow just one tiny piece of your data on its epic, split-second journey across the entire globe. So, let's dive in.
I mean, it feels instant, doesn't it? You type in a website, you hit enter, and boom, there it is. But in that blink of an eye, an incredibly complex and fascinating chain of events kicks off. And that's exactly what we're going to do. We're going to follow that chain step by step.
All right, so first things first. Before our little data packet can even think about going anywhere, it needs an address. Not an address that you and I can read, but one that computers can understand. This is the first, absolutely critical step, finding the exact numerical destination.
Think of the entire internet as just one massive city. You know the name of the place you want to go, a website for instance, but you don't know its actual street address. Well, that's where the DNS, or domain name system, comes into play. It's literally the internet's phone book. Its entire job is to translate that human-friendly name into the precise numerical IP address your computer needs to find its destination.
It's really just a quick little conversation. Your computer asks a DNS server, "Hey, what's the IP for this name?" and the server sends back the numbers. Now this lookup happens so incredibly fast you'd never even notice it. But without it, your request would be like a letter with no address on the envelope. It would have literally nowhere to go.
Okay, so now we have the destination address. Great. Now it's time to actually prepare our data for the journey. You can't just send it as is. It needs to be packaged up correctly for travel across the internet.
And this process has a fancy name. It's called encapsulation. Your data moves down this stack of layers, and at each step, a new wrapper of information gets added on. So the application layer has your actual request, the transport layer adds delivery instructions, and then the internet layer adds that destination IP address we just found.
You know, the letter analogy is absolutely perfect here. It's like each layer is putting your data into a new, slightly bigger envelope with new instructions written on the outside. This is so important because it makes sure that every single router and computer the packet meets along its journey knows exactly what to do with it.
So at the transport layer, your computer has to make a choice. Is this a message that absolutely must arrive perfectly, like when you're loading a web page? If so, it chooses TCP, which is like a super reliable courier service. Or is this for something where speed is way more important than perfection, like a video call or an online game? Well, then it might use UDP, which is more like a speedy no-frills postcard.
Okay, our packet is addressed, it's all wrapped up, and it's ready to go. But here's the thing, it hasn't even left your house yet. Its very first challenge is just to find the exit, your router, and get out onto the open internet.
Now to get out of the house, our packet needs a totally different kind of address. The IP address, that's the global street address for the final destination. But just to get from your laptop to your router, right there in your own home, it uses a local hardware address called a MAC address. Think of it like this. The IP address is the address of the apartment building, but the MAC address is the specific apartment number.
And this presents a little puzzle, right? Your computer knows the IP address of the router, but to actually hand the packet over, it needs the router's hardware MAC address. It knows who to talk to in theory, but it doesn't know how to find them in the same room. So how does it solve this?
It uses this really clever protocol called ARP. Your computer basically shouts out to everyone on your local Wi-Fi network, "Hey, who has this router IP address?" The router hears the shout and replies, "That's me, and here's my MAC address." And just like that, problem solved. The packet gets handed off, and it's on its way.
And with that, our packet has officially left the building. It's now traveling on the global superhighway, that massive interconnected web of networks that we all call the internet.
This slide really shows the internet for what it is. It's not one single network. It's a huge network of other networks all connected together. Our packet is going to hop from your local ISP to a larger regional one and maybe even across a massive Tier 1 backbone, all before it gets to the network where the destination server lives.
Now the protocol that governs this part of the journey is the Internet Protocol, or IP. An IP is designed for one thing: speed. It's connectionless, which means it just sends packets without calling ahead, and crucially, it operates on a best effort basis. It does its best to deliver, but it makes zero guarantees.
Think of it this way. IP just puts the envelopes in the mail. It does its best to get them there, but it doesn't track them or promise they'll all arrive. Now, that might sound kind of unreliable, but it's what makes the system so incredibly fast. The reliability part, well, that's handled by a different protocol.
And speaking of which, let's fast forward. Our packets, or at least most of them, have navigated that global network and have finally arrived at the destination server. And now, the final and maybe the cleverest part of this whole process is about to begin.
Remember way back when we chose our mail service? We chose TCP, the Reliable Courier. And this is where that choice becomes so important. That whole best effort delivery from IP is about to be made perfect by the reliability of TCP. Because packets can take all kinds of different paths across the internet, they almost always arrive jumbled up and out of order. This is where TCP works its magic. It looks at the sequence number on each packet, reassembles them in the correct order, and if it sees any are missing, it sends a request all the way back asking for them to be resent. It's incredible.
So, once everything is present and accounted for and it's all in the right order, the server can finally read your complete request. It then gathers up the website data you asked for, breaks it into its own packets, and sends it on the exact same kind of journey, just in reverse, right back to your screen.
So why does all of this matter? I mean, beyond just curiosity, understanding this journey is absolutely critical for a lot of fields. For cybersecurity analysts, being able to trace this path, to understand the headers on each packet, and to see the origin and destination, that is fundamental to protecting our networks.
Every single time you interact with the internet, this incredible high-speed dance of protocols and addresses is taking place. It's a system built for pure speed and efficiency, but as you can probably imagine, figuring out how to secure every single step of this complex journey, well, that's a massive challenge in itself. Something to think about. Thanks for watching.